Hello everyone. I hope you are really enjoying placement series bootcamp, right? You are really enjoying. So today we are going to discuss bootcamp 3. Today we are going to discuss bootcamp 3. If you have any doubt in the comment section, you can ask. If you have small doubt also there in the comment section, you can ask, right? So yeah, let's go to bootcamp 3. But before going to bootcamp 3, I want to say one important thing to you, right? So EPT having DSA course for placements. Web and app development courses also available with DSA. Languages also available. And we have experience of approximately 25 lakh students we guided. From the last 15 years, I'm guiding the students. This course is going to be really useful. DSA course for placements. In this course, we are going to solve 500 problems from basic to advanced level. 500 problems we are going to solve basic to advanced levels, right? For more details about this course, you can WhatsApp me. This is the WhatsApp number 88208990. If you WhatsApp, right, this particular number, we are going to guide you. Yeah, let's quickly go to bootcamp 3. So bootcamp 3 is going to be finding next greater element. What it means, I given the definition also. Please go through it one time. The definition is saying that greater element, right? Next greater element is to x is nothing but x. So, right, x element next greater element is nothing but right hand side of x you go. If you find out more greater elements, first person is the answer. Next greater element in the given array. For the x, if you want to find out next greater element, x right hand side you go. Whoever is there, find out greater people in that first person. So like that you have to find out for every element. Like that you have to find out for every element, right? So let's see this example also I get. This is the problem. This is the problem, right? Input is this. So see the output. 74 element, right hand side greater person. I think only one greater 125. Okay. 65%, right hand side greater person, only one person 125. So 29, right? Only one greater element on the right hand side 125. 125 greater right hand side no one. So minus 1. Fine. If no one there, minus 1. Right? Next one. So similar way, can you see this array also? 213 element, right hand side greater 1, no one there, so minus 1. 87 element, right hand side greater person, I think 96. 12, right? 96. 87, 96. 96. Right hand side, no one, so minus 1. 12, right hand side, no one, so minus 1. So like that. Like this, we have to find out the next greater for every person. So to this particular problem, you have to write algorithm. If at all many algorithm, you have to write the best algorithm. You have to write the best algorithm. So we'll see answer in the next video. So please concentrate this. Please concentrate this and try to give the answer. If you have any doubt in the comment section, you can ask me. We are going to help you. Right? Fine. So let's see the solution. Right? Let's see the solution for this. To this problem, bootcamp 3 problem, solution is going to be, I think, very simple. Take one for loop, right? One possible solution I'm giving, which is the easy solution. Take two for loops. I think two for loops you have to, because for every element one scan, right? Two loops you have to take. Time complexity order of n square. Two loops you have to take. Some people are asking, sir, how, sir? Right? Let me take some elements. See, already some elements I'm taking. See, take this element first. This will be compared with all these people. Right? 110 you take, compare with everyone. Suppose in that position 0. 1, 2, 3, 4, 5, 6. So if the I value is 0, J value start from 0 plus 1, 1. See, I value starting from 0. I value starting from 0. J value will start from 0 plus 1 onwards. So this 0 will be compared with 1. If it is a greater, stop and print it. So 110 will be compared with 113. Greater, stop and print it. In the similar way, see this one. If at all this condition true, So, right, so store it. Next greater is going to be this person, so break it. So you will come out of this, so you will print it. Right, remember this for loop you are breaking, right, you are printing. Next I value you will go. So as soon as you print one person, you cannot stop it. Right, inner loop will be stopped, outer loop will continue. Next I value 1, I value this, I value 1. So J will goes to from here. So 113 compared with 121 greater. Right, stop it and print it. Right, then break. Then go next. Next I value this. Next I value 2. J will go from here. So wherever you find out the greater person, right, stop it and print. So worst case, first person will be compared with all other people. Second person will be compared with all other people. I think n times linear search. So this is the program for this. N times linear. It's a Python program. N times linear search. N times linear search. So this is the program also. I written the program also. Some people are asking, sir, can you explain the program? So this is the main program. So main program, I took one array, NG, next, right, next grade, next greater. I called the function. So there are two for loops. Nothing there here. There are two for loops. There are two for loops. Right? Try to understand this. This entire thing. This entire thing. You break, you will come outside, you will print it. Right, see this one. You break this particular for loop. You break this particular for loop. You will come out of this loop. You will print it, and you will go to next value. Remember, these all will be there. If anyone has a small doubt also about this code, right, write properly. Right, so I will just give the little more clarity. Right, this is the problem with the Python. Right, so you should keep the gaps properly. See this one. This for loop. This for loop is going until here. Right, this for loop is going until here. Right, each I value, see one, each I you have to print. Each I you have to print. So whenever you break, you will come outside, you will print it. Whenever you break, you come outside, you print it. So like that, just keep on going. So this will be compared with all other people, worst case. This will be compared with all other people, worst case. So like that, n times linear search. So linear search will take n times n square. So this is the one algorithm to solve this problem, n square. So space maybe you are not taking anything space extra. Let me write. Time complexity order of n square. This is the time. Space is, I think, constant. You are not taking any extra space. Extra space is constant. Because I think I don't see you are taking some, right, extra array, right? Just you are taking some local variables and you are doing that stuff. Right? Let's move to another best answer. Another best answer. I written the program also. Let's see the another best one. Right? Another best one. Please observe here. Start from main program. One array you took. Right? Call the function. Right? You call the function. So let us in the function name is print. So function name is ng. You can give whatever name you want. I return ng. Function name is ng. So ng, it will go here. So what this algorithm doing? Let's explain. Very interesting algorithm. That is the reason program looking like little bigger. Forget about the code. Only for namesake I written the code. You can see that code. So let me explain the logic. Everyone observe. 250, 250, 150, 100, 70, 300, 180, 39, 46, 770, some numbers. So remember, this problem can be solved using stack. Take one stack first. Observe clearly. Take one stack first. Okay. First person, push inside stack. Okay, that is also okay. Remember, it's very simple. Very simple. Take one stack. First person, push. First person, push. Okay, fine. The next person, whoever is coming, ask Is next person is greater than the top of the stack? No. If not greater, we are looking for next greater, right? So if the next person is not greater, push him. No use, push him. Next one. Right. Now top of the stack is 150. Comparing this 150, is next person greater? No. Then push it. Comparing the top person, is next person is greater? No. Push. So if the next person is not greater, push. If the next person is not greater, comparing top of the stack, push. If the next person is greater, everyone listen. If the next person is greater, yes, comparing top of the stack, next person is greater, then what you do is, whoever is the top of the stack is there, pop him, and because of, right, comparing 70, next person is greater, right? Pop him, and print to 70 next greater is 300. Print it. You popped this one, print the 70 300. 70 next greater is 300. But remember, you popped this one, you printed, it's okay. But still, it's only next one. Next one is this only. This will be compared with the, again, next top of the stack. Right? Comparing 100 also, 300 is greater? Yes. For 100 also, next greater is 300. That also pop and print it. But remember, next greater still this only. This is the important thing which you have to identify. Right? So now whoever is the next top of the stack C, that will be compared with the next greater. Yes, still greater. So what is the answer? For this also 300 is next greater. Pop this and print. When you printed means you popped out. Next one. Right? Now next top of the stack is 250. It will be compared with the next greater. Yes, still greater. So pop this one and print it. Then pop this one and print it. Yes, next one. Now 300 want to compare next top of the stack. Not there. If not there, push it. So fine. So from now onwards, again normal story. Let's see once again. So next person coming 180. Is he greater than the top of the stack? No. Not there means push. Next one, 39. Is it greater than the current top of the stack? No. Push it. 46. Is it greater than the next, right? Is it right? This 46 is greater than the current top of the stack? Yes. Then what will you do? Pop it and print it. But remember, is the right next element. Still it is the next element. Now this will be compared with current top of the stack. No means push. Next one, 770 is greater than the current top of the stack. Yes, push it. Because of no one is there for that. Stop it. Remember the people who are there. So you popped it. So, sorry for this one. Sorry. This 770, whichever is coming, is it greater than the right existing top of the stack? Yes. Then what the answer? Pop it and print. Sorry for this. Pop it and print. Okay. Next one. The 770 is greater than the current top of the stack? Yes. Pop it and print it. Next one. The 770 is greater than the current top of the stack? Yes. Pop it and print. Next one. The 770 will be pushed inside stack. Right? Now afterwards no one, so he will also be popped out. Because of he is the last person. Because afterwards no one. Print minus one. This is the way. Again I'm asking you. Some people are asking, sir, can you repeat? Reddy sir, can you repeat once again? I'm going back and once again I'm repeating. Everyone try to understand. Some more random elements let me take. Algorithm also available. I will explain. First, understand the logic first. And again, I'm doing the same story one more time. If anyone has small doubt also, you can see once. This problem can be solved using stack. One scan only. With one scan, you can do it. Some people are asking, sir, can you explain again? I will do it. Yeah, don't think much. I will explain one more time. Let me take some more random elements. I'm taking some more random elements. I will explain. 6, 92, 42, 68, 120, 33, 88, 23, 46. Right? Next one. Right? 13. Some numbers. Right? See everyone see this. First element push. Remember, if more coming, then only you have to pop. If more coming, then only pop. Right? See. So first person push. Next one. So comparing current top of the stack, is it more? No. Push. Right? No means push. Right? Suppose greater coming, then. So this also done. Next one is comparing current top of the stack. Next one is greater. Yes, yes. Then pop it and print. Pop this one and print it. You pop it, you print it is okay. But remember 68 still. 68 is still. Right? Remember until this 68 will come inside stack. You have to take this only. You have to wait this person until he will come inside stack. Because of 68 not came inside stack, you have to stand there only. Again, who is the top of the stack? 92. 92 and 68. 68 greater? No. If not greater, push. Now he came, now go further. Next one, 120. Comparing current top of the stack, 120 is bigger. Yes. If it is bigger, pop. So what is the answer? 68. 120. Bigger pop. Remember, this 120 not came inside stack. Until it will come, you have to take this only. Now, current top of the stack 92. 92 is comparing 92 to 120 greater. Yes. Then it is greater. You have to pop. 92 to 120. Pop. Now next one. Right. Next one. Inside stack, no one is there. Then push. Okay. Another push. Now the next person who is coming is he greater? No. The next person who is coming is he greater than current top of the stack? Yes. Then what is the answer? Pop and print. Now, because of 88 is not came, you have to still compare with this. 128, 120 and 88. It's not greater. Not greater means push. 23. Not greater means push. 46. Is it greater? Yes. Then what is the answer? Pop and print. Right? Next one. 88 and 46, no. Push. Next, 31. 13. 13 is greater, no. Push. 13 is greater, no. Push. So, like that you done it. All people can now observe. Clearly. Whoever is there in the stack, if you want, you can observe. After 120, whoever came, all are smaller. After 88, whoever there, all are smaller. After 46, whoever there, all are smaller. Right? Whenever total array is over in the stack, still some more people are there. Very simple. Pop everyone, print -1. Pop everyone, print -1. Because it's not possible. Pop everyone, print -1. Pop everyone, print -1. So like that you have to do. Right? Now let me give the guidelines once. First person push. Right? Next one. Whoever is coming next one, if it is greater than current top of the stack, if it is a greater, pop and print it. If it is smaller, push. For more clarity, I written the program also. See this one. These are the elements. Call the function. So array is went here. One stack I have taken. It's okay. Right? So element 0, next is 0. See this one. First element push. Okay. Until here, okay. First element push. Now one for loop is going on. Right? Because whichever element you push to, that person you have to take care. Some people are asking, sir, this for loop is until where, sir? This for loop until here. This for loop is until here. Careful. Right? So for loop is started, one element is already pushed, for loop is started. For loop means what? These all elements should be over. That is the meaning. First element you are taken, one for loop is started. Now see what happened. Next is equal to AR1, right? Next element is this one, that will be compared. Is stack is not empty? Yes. Then if it is not empty stack, so pop the element, compare it. If at all after comparing, next is greater, then what is the answer? So then you have print right element, print next, print it. Right? Next one is stack is in, right? Stack empty true. If empty, you can break and you can come outside. That same story will going to keep on going. Suppose assume that, right? Whenever this loop is going on, right? Stack is empty, then you have to break. If stack is not empty, Empty true means then break and come outside. If not empty, condition fail, again loop is going on. Same story, whatever I done. The element is less than next. Element is less than next, right? This while loop is keep on going, right? Whenever this while loop is fail, means element is greater. If element is greater means next is not greater, element greater. Element means small k, then push. Same whatever I explained, same thing there. Please see the code one more time. Please see the code one more time, right? So remember until here. This is the until here for loop. Please check whatever I discussed, same thing there. I hope you got it. If anyone having little doubt also, right? You can see the code and you can comment in the comment section. I'm going to help you. See this one. Next is more. Next to more, right? So comparing the top, next to more. Then what is the answer? If this is true, if next to more, pop and print. Comparing the top and the next to top is bigger. Push. These are the two lines. These are the two lines which you have to take. And one more. Stack. See this one. In the stack worst case, all elements will come, all elements will go. More than nothing will happen. One scan, order of end time. All push operations, all pop operations. This is the maximum thing what can happen. Otherwise, in between what happened? One will go, one will come, one will go, one will come, one will go, one will come, one will go. That is also order happen. It don't take beyond the end time. Order of the end time, but the problem is the time extra space if you observe one stack required. Extra space if you observe one stack required. Order of n. Right? The stack size is order of n. Maximum order of n. Maximum order of n. So in the case of best case, one element only will come. See, best case, one will come, further, right? Maybe all will be popped out. Right? Best case only one, constant space. Worst case n space. So worst case. Right? Best case maybe one space, constant space. Right? But here time complexity every case. Time complexity every case. Right? I hope everyone got it. Right? So thank you. Right? Small doubt also there. You can ask in the comment section.